Okay, here's your last mole video, and so mole video number 3. I broke this down into 3 separate videos so they weren't so long. Your first one was pretty long. Your second one was pretty short. We'll see how long this one gets. I don't know. Okay, so the first thing I'm going to show you is a mole problem flowchart. In the last 2 videos, I showed you one kind of problem, and we kept with those problems through the whole thing. In this last video, I'm going to show you the last kind of problem, and then you're going to have practice problems on all the kinds. So it kind of shows you where we're going. So you could have a mass problem. You would use molar mass to get to the mole of substance 1. If you were using your particles, so atoms, molecules, ions, formula units, anything like that, you would use Avogadro's number, the 6.02 times 10 to the 23rd, to get to your moles. The thing we're going to learn today is a mole ratio. Okay, and so that's right here in your little flowchart. So conversions from mass to atoms, and then atoms to mass. So basically, we're going to combine the 2 steps that we've already learned into a 2-step problem. So how many atoms are there in 23.5 grams of lithium? So basically, you're going to start exactly where we would start in the previous problems. We would write down what we know. So we know we have 23.5 grams of lithium. And from this point forward, it's going to be important to put that lithium on there. In the past, we haven't, didn't really matter. From this point forward, you're going to want to write what it is. Okay, lithium. Grams of lithium. So if you don't know how much lithium weighs, you're going to need to find that on your calculator, or on your periodic table, excuse me. So lithium weighs 6.94 grams, and grams, diagonals have to match, right? So 6.94 grams, and we know that mass equals 1 mole, right, of lithium. Now, are they asking me for moles? No, they're not. They're asking me for how many atoms. Once I get to moles, this is a 2-step problem. I can find anything. I can find atoms. So I know moles goes here, and 1 mole of lithium, 1 mole of anything, really. There's 6.02 times 10 to the 23rd atoms of lithium. Excuse me, I'm running out of screen space. I was writing too big. Okay, so how do we calculate this dude? Okay, I'm going to say everything I'm doing, whether or not I need to do it or not. So, this guy here, 23.5 times the 1 times this whole thing, 6.02 times 10 to the 23rd, divided by 6.94 divided by 1. Realize the ones you don't actually have to do, but so what do I get? Now I'm gonna have 3 digits in my answer because they gave me 3 digits, okay? So 2.04, I'm rounding up because it was 3/8, times 10 to the 24th atoms of lithium. If you are talking about atoms, you would expect your number to be times 10 something. Okay, that would make sense. Okay, this is basically as hard as it gets, folks. So, as hard as it gets isn't that hard. Okay, so on to the new stuff. Moles of compounds. So, chemical formula. Okay, H2O. You know what H2O stands for? Water. In water, we have 2 H's and 1 O. So the chemical formula of anything tells us the number and types of atoms in that compound. So Freon, and realize this should be written like this. I should have corrected that somewhere in translation. It got lost here. So these should be little 2's. Okay. But in this formula, we have 1 carbon, 2 chlorines, and 2 fluorines. We could also write this as a ratio. We could say the ratio is 1 carbon to 2 chlorines to 2 fluorines. We could write this as a mole ratio. Okay, we could say in 1 mole of Freon, you have 1 mole of carbon, 2 moles of chlorine, and we could say we have 2 moles of fluorine. You can write mole ratios as a fraction, and that's how we use them in our dimensional analysis as our conversion factors. We could say we have 1 mole of carbon to 2 moles of chlorine. We could reverse that and say we have 1 mole of chlorine to, 2 moles of chlorine to 1 mole of carbon. We could say we have 1 mole of carbon to 2 moles of fluorine. We could reverse that. We could say we have 2 moles of fluorine to 2 moles of fluorine, and then that could be reduced, right, to 1 to 1. And we can flip that. So all these ratios can be written, they can all be reversed, however they need to be used. The important thing is that we can write mole-to-mole ratios of a compound with elements within a compound, and that will be used in these next few problems. So how many moles of fluorine atoms are there in moles of Freon? So if there are 5.5 moles of this whole thing, in 1 mole of that whole thing, there are 2 moles of Freon, or fluorine, excuse me. So we're basically going to double it. So it's 11 moles of fluorine. Okay, so you see how that works? You can kind of do it in your head, but you could also write it out so that it's more apparent and you can use it in other problems. How many moles of carbon are there in this little guy, in C6H12O6? So in 3.50 moles of this stuff, how many moles of carbon in there? Well, in 1 mole of this stuff. Now, do you guys notice the abbreviation for mole I'm using? I'm using MOL. I don't know why that's the abbreviation, but that is the abbreviation. So in 1 mole of the stuff, there's 6 moles of carbon. So it's 3.5 times 6. Just double checking now on my calculator, that's 21. So for significant figures here, that's 21.0 moles of carbon. Okay. We're going to go over a couple more terms here before I let you go. Molar mass. Molar mass is also known as atomic weight, molecular weight. It can be found by looking up the masses of each element, multiplying by how many atoms there are, and adding them all up. It's not a hard concept. Once you learn the concept, I'm going to show you a shortcut that you will love. C2H3O2 is acetates, something that's actually quite common in chemistry. So what we're going to do is we're going to have a periodic table. So I'm going to pull up a periodic table. I'm going to look up the molar mass for carbon. Carbon is 12.01. I'm going to look up the molar mass for hydrogen. Hydrogen is 1.01. We're going to look up the molar mass of oxygen, and oxygen is 16. We're then going to multiply by how many there are. So there are 2 carbons, 3 hydrogens, and 2 oxygens. We're then going to add all those up. So you can do this separate steps. You can do this all at once. It just depends what's going on. So 12.01 times 2 plus 1.01 times 3 plus 16 times 2. If I do all that, it's 59.05. And remember your units for molar mass? Did we forget already? Grams per mole. I will ask that you show your work for 1. And after that, once you get in the habit, you won't have to show your work anymore. Okay, so converting moles of a compound to mass. So just like for elements, you're going to find the molar mass of the compound, and then you're going to convert from moles to mass or mass to moles. The only thing is you have that additional step of calculating the molar mass first. Again, once you learn how to do it, I know you know how to do it. I'll show you a shortcut you can use on your homework. I won't allow you to use that shortcut on quizzes, but I will allow you to use that shortcut on homework, okay? So I'm going to do this example with you, and then I will let you go. And notice there are no practice problems for this video. You're just going to jump into some assignments. So what is the mass of 2.5 moles of water? And remember, we have to get in the habit of labeling everything. So 2.5 moles of water. Diagonal from that, I have to put 1 mole of water. In here, I need to know the grams of water. So water, I have H and I have O. H is 1.01, and there's 2 of them. And O is 16 times 1. So this is 2.02, and this is 16. So this is 18.02 grams of water. See how easy that one was? That one we could do in our head, basically. Okay, so we have 2.5 times 18.02 divided by 1. Our answer is, and I'm going to write it up here just so that you're not confused by all my mess, grams of water. And actually, sorry, 2.5. So for significant figures, just go with 45. 45 grams of water. Okay, we're going to end here, and the next assignment is your mole worksheet number 1. Let me know if you need any help.